Hey everybody, this is Alex Merced from alexmercedcoder.com, and this video is about programming, and not just about programming, but about programming languages. And my goal in this video is one to give you an idea of all the different languages that are out there. No, I mean, it's going to be impossible for me to name every single one. There's endless amounts of them. But kind of give you an idea of sort of what their roles are, where they typically are used, so that way you can kind of decide where you'd like to specialize. Because I mean, the reason why there's such a huge demand for programmers is because there's just like one thing is to learn one language, but then within each language there's a lot of specialization. So you could literally spend your whole career just doing JavaScript and just doing, let's say, mobile apps using NativeScript or a React Native, and that could literally be your whole career. And that's just a small little subsection. Or doing backends and whatnot. So I mean, in any language, there's a lot of specialization just within that. So it's a huge field. Although your ability to sort of move around that field of different languages and different frameworks and different libraries and different situations really comes down to your fundamental understanding of programming. So regardless of what programming language you decide to make your first programming language, I'll kind of give you some recommendations which are sort of good starter languages. I mean, they're good languages in general, and they do, there are plenty of jobs in them, but the idea is that they're like easier place to start. Um, and actually, let's just start with that. Like, let's start off with sort of the good languages for if it's your first language. Okay. So, good first languages. I think JavaScript. JavaScript is interesting. I mean, you're gonna have to learn JavaScript pretty much unless you're not doing anything at all with the web or anything kind of visual for the most part. Um, and that might not necessarily be the case in the future. We'll come back to that. But JavaScript is a really flexible language, has a lot of, it's really easy to learn. It's very difficult to master. And you'll hear a lot of people say that. The reason is JavaScript has a lot of way to do things. So finding out how to do things can be pretty easy because you can generally find some way that works for you. But having an appreciation of all the ways you can do things and how that opens up all sorts of new doors for you takes a while and takes a lot of curiosity. Python is a great first language. The syntax is very easy. Same thing with Ruby. These are all, like, these three languages are pretty quick to pick up. Okay? So these are good starter languages. But when you learn these languages, it's not just about like learning the language. It's like the language is just a means to an end. What you want to learn is the whole idea, the concepts of programming. Okay, so you want to be understanding things like data, okay, and types. So understanding that different types of information that you're playing around with comes in different types, and you have to understand sort of what's being passed around your program and appreciate that like a string is not an integer, and an integer is different than a float. That seems pretty straightforward. Like a string, some letters are letters, but how it moves around in the machine, how it takes up space in your memory, that's really it takes some time to really fully appreciate that. Control flow. Okay, control flow is like basically ifs and loops. So the idea is that you might be able to write a code that says, hey, this variable is equals this. But code gets more interesting when it starts branching in different directions. When your code does one thing in one situation and another thing in another situation. Or repeats a task. And that's all with control flow, where basically your code is no longer procedural. It's no longer just one command after the next. It now takes on branching paths because of ifs and loops. So understanding how that stuff works is pretty fundamental to all programming languages. Functions and the concepts of functional programming. Okay? So basically functions are something that pretty much exists in all programming languages, and basically what it is, it just allows you to sort of bundle bits of code so you can rerun them again whenever you need to. There's a lot more to it, and then there's a whole sort of paradigm called functional programming that basically uses that concept of a function and use it in different ways to accomplish great things in programming. I highly recommend learning both. Okay, and I'm not saying you should only be a functional programmer, but understanding functional programming techniques will make you a good programmer and a better programmer in any language, because it just helps you think about problems in different ways. Same thing with understanding objects, which usually come in the form of classes, and what's known as object-oriented programming. So when you're talking about objects and classes, the idea is we're now starting to take lots of data and encapsulate it into something that's more understandable, in the sense like, let's say a baby, okay, and then there's like certain things that a baby does. So these are generally like functions of an object, also known as methods, and then there are properties. And this whole sort of way of designing your program around objects and using this idea of creating objects in your program to interact with each other, this is referred to as object-oriented programming. So understanding concepts like inheritance and polymorphism and all that stuff. So, and again, this is stuff that applies to any programming language. Understanding it will make learning any programming language that much easier. Okay? And then, of course, just understanding, and then there's also collections, just understanding how bundles of information are collected in things like arrays, maps, sets, etc. And also just understanding the basic concepts of memory, which make all these other things make much more sense, as far as why you have certain options available to you. So knowing that, like, in certain languages, like in JavaScript, Python, and Ruby, these are what's referred to as higher level languages. Okay, and what this means is that they do a lot of things for you, particularly in regards to memory management, by doing something called garbage collection. Okay, so in lower level programming languages, they don't do that for you, which means you have to program how the memory gets managed. Okay, so which languages are lower level? Okay, meaning, and generally they're going to be more verbose, meaning you're going to have to do a lot more code, a lot more lines of code. A lot of the work is on you. Okay, so this would be things like C++. I put C in that category because it's pretty much the same language. One just doesn't have the object-oriented programming features and some slight syntax differences. C++, I would consider Java in that category in today's world. Go, Rust. Go and Rust are newer languages in this space. But you would go to these languages because they're going to give you some more control over how your program uses memory, which means you're going to be able to make your program faster. This is really important for really memory-intensive programs. So think like video games, operating systems, or really heavy-duty backends for websites. They're probably going to prefer using one of these, because even though it's a little bit more work, a little bit more code, it's going to run a little bit faster, which can really make a big difference for really big applications. Okay, so that's what's the deal with these languages. This is why generally maybe not the best for your first language. Start with one of these. Okay, cool. But so basically, and I'm just going to give you an example. So an array is like a collection of variables. In a lower level language, you have to specify how big that array is going to be. Like, does it hold 3 variables? Does it hold 4 variables? And the reason you do that is so that way it allocates the right amount of memory. Okay, and so you're constantly having to think about what your data looks like. In these higher level languages, you often don't have to think about the size of your arrays. If they just handle arrays differently, and all that underlying managing of memory is done for you. So when a variable is no longer being used, it'll just go out there and remove it from memory for you. It will resize and reallocate memory behind the scenes for you, which is great. Makes for a much easier and better quality developer experience, and makes it where you can make stuff faster, but at the cost that the program might run a little bit slower at huge scale. Again, for smaller, medium programs, you're probably not going to notice the difference. And even then, there are ways to optimize your code. So I would say, for the most part, you could probably get pretty satisfactory performance with these languages at even pretty robust programs. But that's sort of the trade-off between higher level and lower level. Okay, now if you want to go even extra lower level, okay, so we're going to go super lower level. Okay, then there's machine language, which is actually like all the zeros and ones that this is what the actual computer actually reads. Everything ends up there. That's literally everything has to go there. So, I mean, they kind of give you sort of a hierarchy, a little history, kind of. So machine language was basically how the computer thinks. It takes forever to kind of do something there. So they kind of, every time you hear the word abstraction, when they abstract something, think of it as they made a more readable, easier to understand version or layer. So the abstraction over machine language is assembly, which was sort of the first step in making things simpler. And then you kind of get into C++, and these are, so most lower languages are abstractions over like assembly and machine language, and then these higher level languages are generally abstractions over these lower level languages. So for example, like a lot of JavaScript engines might be written in C++. So basically it goes from JavaScript to C++ to assembly to machine language for the computer to actually like read or something like that. Now if that's the exact chain that it goes through, maybe not, but that's the way to think about it. Okay, so far we'll just to recap what we've learned is that higher level languages are going to be the easiest to learn up front. But at the end of the day, your focus shouldn't be just learning one particular language, but understanding these concepts so that way you can be a good programmer, because these concepts are portable among all, for the most part, all languages. Okay, let's list a few more in these categories that we got so far. So in higher level, so Ruby, Python, and JavaScript. Ruby and Python are pretty general use languages that you can use for pretty much anything. And but Ruby is probably most well known for creating website backends using Ruby on Rails. There's a lot of other frameworks for doing, website servers, but Ruby does other things. So you can make other types of applications. I think you can even do mobile applications now in Ruby. Python is probably most well known for like data science stuff, but I mean it's in blockchain, it's in web with like Django and Flask and Bottle, doing like web backend servers. It's in, you can do desktop applications using I'm forgetting the name of the library at the moment. Okay, and then if you wanted to do like mobile applications, you could use a library called Kivy. So you can go a long way with Python. And then again, it's not a hard language to learn relative to other languages. Programming is hard to learn up front because it's a new way of thinking. And if you've never been in a situation where you've broken down problems in the way you do in programming, it'll take you a while to develop that programmatic thinking. But if you're persistent, one, you'll get there, and programmatic thinking will actually improve your ability to break down all problems, not just in programming, but in your life. So it's a very worthwhile skill, programmatic thinking. JavaScript was mainly a web language. It was like the web language. Basically, what's happened is it's evolved. It's everywhere. So you can literally create desktop applications with JavaScript using Electron. You can create mobile applications with JavaScript using React Native and NativeScript. So you can use JavaScript pretty much everywhere. And then in more recent times, Microsoft has created sort of a souped up version of JavaScript called TypeScript, which is a lot of fun. It kind of adds a lot of the cool typing. Well, it's not. I don't know if people think typing is cool, but what typing is that generally in these lower level languages, every time you create a piece of data, you have to tell in your code what kind of data is it. Is it a string? Is it an integer? And the reason you do that is so that way when you compile the code, meaning you actually turn the code into something useful, the thing that compiles it, the compiler, can pick up on errors. Usually these higher level languages are interpreted, which means they aren't turned into like a final form of code. They're kind of read and run on the fly through an interpreter. So usually you don't have to do much in the way of typing because you'll just run into an error when it runs. So Microsoft created this, which adds typing to JavaScript. So it's cool. I like it. Okay. So let's keep going. Also, let me add WebAssembly over here. Wasm. Okay, WebAssembly is again, you would never probably write much in the way of WebAssembly code, but it's a thing that browsers can now read. So now in the future, because right now the only language your browser for the most part reads is JavaScript. But in the future, people will be able to create WASM compilers. So that way Python code can be compiled to WASM. Ruby can be compiled to WASM. Rust can be compiled to WASM. Go can be compiled to WASM. You guys get the idea. So in the future, where can you do front-end code, meaning the actual visual part of your website? You'll be able to do that with pretty much every language in the future. Right now, it's still pretty much just JavaScript. Cool. Then we have Swift. Swift is kind of what replaced a language called, well, not replaced, but Swift is what's used to make iPhone apps. And it was meant to replace the old language that's used to make iPhone apps, Objective-C, which is a more lower level language, which made making iPhone apps a little bit harder than it needed to be. But people still use Objective-C, so it's, you know, a language people still use. There's still jobs in it. Yeah. Then there's Kotlin. Kotlin is like the same thing, but for Android. Again, Swift and Kotlin are a language that can do anything, but they've been mainly embraced for the purposes of mobile apps. Kotlin basically taking the place of Java for making Android apps, Swift taking the place of Objective-C for making iPhone apps. Cool. So that's those languages. Then there's Dart, which Dart is a language that can be used for all sorts of things, web, mobile, whatnot. It's probably most well known for something called the Flutter compiler. And what it allows you to do is it allows you to create mobile apps using the Dart programming language that work on iPhone and Android. So using one language to create apps for both devices. So that's a cool language. And it's very JavaScripty. Let's see here. Other languages I want to add. There's so many. Okay, let's talk about, since I've already mentioned Java, let's talk about the Java virtual machine for a moment. So actually I'm going to make a new slide. Okay. And I'll just do this, the Java virtual machine. Okay, so Java, the big deal with Java was when it was created is that it had its own runtime, because what used to happen is that you would run a desktop application on your Windows computer or on your Mac computer, and then the programmer would have to program it specifically for Windows or program it specifically for a Mac. So you always had compatibility issues, and the program you wanted wasn't available on your particular computer. You still have this today. So the promise of Java was write once, run anywhere. Although one can argue that JavaScript is actually fulfilling that promise a lot more these days. But the idea is that you would have this, what's called a Java runtime. You'd have this little virtual machine that runs Java code that would work on a Mac, that would work on a Windows, so you could run a Java program anywhere. But this is also referred to as the JVM. But over time, people started creating all sorts of other languages and taking other existing languages and making them compile to JVM bytecode, meaning they could run in the Java virtual machine. So if you wanted to create a program for the Java virtual machine, which a lot of big companies use, you would use one of these languages. So of course, Java can be used for the Java virtual machine, and Kotlin we've already mentioned. But there's other languages like Hax, Scala. There's a bunch more, but those are the ones that I can kind of think of off the top of my head at the moment. So, and there's implementations of many of the existing programming languages for the JVM. But that's the whole thing. Like working in the JVM and virtual machines is like a whole specialization career in itself. But again, all those same concepts still apply. Object-oriented programming, all that fun stuff. Cool. Let's talk about the .NET ecosystem. So Microsoft created the .NET ecosystem, which is basically kind of its own world of programming. Again, same programming concepts, but they kind of took what Java was doing, because they kind of, again, here's kind of the lineage. First, it was like C++ was sort of like the big deal back in the early 90s. So then, was it Sun Microsystems creates Java, and they wanted to create Java to compete with C++. So they borrowed a lot of ideas from syntactical ideas, so that way it was similar enough to C++ that most programmers would be willing to switch. And but then Microsoft responded because they didn't like the whole idea of like write once, write anywhere. So they created C# as a response to that. So it was like another version of Java, and this kind of evolves into the .NET ecosystem, where they create their own runtime. So kind of like how Java has their Java virtual machine, Microsoft creates their own version of that, the .NET runtime. And the languages you can use to create stuff in that .NET ecosystem are C#, is probably the most popular one. Then there's F#, which is sort of a functional programming language. I'll talk more about that again in a second. And VB.NET, which is sort of a newer version of an older language called Visual Basic. And you could also use C++ in this environment too, but these languages were kind of made specifically for .NET. But you can use these in that, and this works in that sort of Microsoft infrastructure. They have their own frameworks for all this stuff, their own tools for all this stuff. It's literally sort of its own, like, you could spend your whole career specializing in just the .NET ecosystem, never learn everything, and never need to venture outside of it. Generally, really, really large corporations are going to use .NET, and they're going to hire .NET developers. So they're fairly well-paying jobs, but generally, much larger corporations are going to be much pickier about who they hire. They're going to weigh things like having a computer science degree more than a startup or a medium-sized company, while a medium-sized smaller company is probably more likely not going to be using .NET but using like Ruby, Python, JavaScript. So these are sort of the considerations when you decide sort of how you want to pursue this, how you want to move forward. And there's always a lot of hiring for Java as well. Okay, so moving on. Then there's functional languages. Okay, and in functional languages, these are languages that were designed for particularly to facilitate functional programming. So that whole paradigm of, you know, doing everything through functions. And there's all sorts of really interesting concepts as far as higher order functions, currying, anonymous functions. It's actually a really fun field, and again, it's worth learning what functional programming is, because it will make you a better programmer, because it just shows you a lot of cool techniques that are useful. But there are languages that are literally built just for this purpose, that include Haskell. So sort of the ones that people always like, the overarching ones are like Haskell, Lisp, Lua, Scala, and then in modern times they've made a sort of more modern version of Lisp called Clojure. That's kind of picking up steam in the functional circles. There is Elm, which was a functional language purely for making like websites and, you know, creating sort of unbreakable code. And then there's Elixir, which I think is sort of a web version of either Lua or Haskell, but also created specifically for like web applications. And then F# is also a functional language, and I think that's also based on Haskell. Haskell is supposed to be really hard to learn. It's one of those languages I haven't tackled yet. I have played a little bit with Clojure and Elixir. And one of these languages is a bit more of a jump. Yeah, it's like if you learn the languages I've listed already, these are going to feel a little bit more of a transition versus other languages. And I'm pretty sure there was another language called Scheme that I want to add to this list. It's called Scheme. It's actually technically what JavaScript was based on. When they created JavaScript, they were pulling ideas from Java, from Scheme. It was literally, JavaScript was created in 10 days. It's a really interesting history. JavaScript is super fascinating. Okay. Now let's just talk about like a few niche languages. Okay, there's Ballerina. Ballerina is a language that's created for, it's specifically designed with cloud in mind. So basically, most programming languages, you build stuff to work in the cloud, but they weren't designed around working with sort of like Amazon Web Services or Microsoft Azure. They're not designed for this sort of new paradigm. Ballerina is supposed to be like a language for web development that focuses on facilitating that type of development. Crystal is just another language that was created for the purposes of web development. I'm not quite sure what sort of the what makes it special, I guess. But it's another language, just so you're aware. You know, the more you know. And I'm trying to think of other really kind of interesting sort of niche languages. Okay, well that's escaping. If I think of any more, we'll come back to this page. Okay, and then now we're just going to reiterate certain specialties, just as again to reiterate like what you would use for certain things. So for web, I think we've covered a lot of it pretty well. But if you want to focus on like things like mobile, again, the key languages are going to be Kotlin and Swift for making native mobile applications. But with JavaScript, you can make mobile applications using React Native or NativeScript. These are two libraries within the JavaScript world. If you're using .NET, any of the .NET languages, you can create mobile apps using Xamarin, which is a library for making mobile apps in the .NET world. You can use Ruby has a library. I don't know what it's called, but there is something there you can make mobile apps with. If you are using, you can use Dart. Dart's built for that purpose. Oh, and there's Python with Kivy. So Python's Kivy library will let you build mobile apps. So you got a lot of options, okay, if you want to build mobile apps, which is again a good consideration when you're trying to think, well, what language is going to give me the most mileage? But again, I do recommend learning, at least learning the basics of 2 or 3 languages, because then you start seeing what's similar between them and start appreciating the differences and appreciating that there isn't that much that's different. Let's talk about gaming. I haven't talked much about gaming yet. So generally, if you want to make video games, you're going to use one of like a few different gaming engines. The Unreal Game Engine, Unity, or Godot. Okay, Godot's like the open source gaming system that's free, so you can just download that, start making video games. Unity and Unreal, they have like free versions, but there's all sorts of different licensing agreements and revenue sharing stuff you have to kind of look into. But generally, for all 3 of them, you can use C#. There used to be more languages that would, and there are more languages that these can work, but I'm pretty sure all of them can use C#, and that's generally what people do. So if you're looking to make video games, then C#'s your boy. Okay, there are pretty much every programming languages may have some gaming libraries for creating games, but at the end of the day, that's sort of, in video game world, that's what you use. I think that's a pretty good review of programming languages that exist. Let me just add a few more. So let me just make one more tab for, or actually let me just go back up here to the first one. There's a few I want to come back and add. I want to add PHP. PHP is a purely web language, but it's a very popular language. It's like more than 50% of websites use PHP to some extent on their backends because they use WordPress. And there's still a lot of other PHP websites that don't use WordPress that use PHP. So it's a fairly robustly used language. And then now I think we're on PHP 7, and there's been a lot of improvements from PHP. People usually complain about PHP. They're probably talking about PHP like version 3, when there was a lot of security issues. But PHP has fixed a lot of that, added a lot of new syntax. It's a lot cooler language. Same thing with Perl. Perl is even older than PHP. And you'll hear a lot of people say negative things because it's so old. But they do have a new version of it. They've actually renamed the newer version of Perl Raku. And then that's a cool thing. And that, who knows, that might make a comeback at some point. With that, I think I feel we have a much more complete list. I mean, you can go back and find all sorts of really fun historical languages. There are other languages that exist in the JVM, like the Java Virtual Machine has a whole bunch of languages that run through it. There's a lot of other sort of weird niche languages, but this should keep you covered in understanding sort of the landscape of what languages are used a lot and what for, and give you a clear idea of maybe what you want to do and how you want to think about things going forward. So thank you guys very much. Have a great day and enjoy.